Okay, looking at equations of tangents. Now, as we know, the differential equation is the gradient function. So if we know the differential equation, we can find the gradient at any point. Usually you're going to get this asked one of three ways. One where you're given the point, one where you're given the x value, and one where you're given the y value. So let's look at the first one. Here we're given a point. So so find the equation of the tangent of the curve. Y equals x cubed plus x squared plus x plus 1 at the point -2, -5. So the gradient, remember dy by dx, your point, if you have to find it, you sub into the y equals. I kind of put them up there. I usually use kind of pink or a light colour to kind of make it, that's your thought process. So gradient, there's our original equation. We need dy by dx, so dy by dx, 3x squared plus 2x plus 1. Remember that 1 disappears, the x becomes a 1 and so on. At x equals -2, m equals 3 lots of -2 squared plus 2 lots of -2 plus 1. So -2 squared is 4 times 3 is 12. 2 times -2 is -4 plus 1. So 12 take away 4 is 8, add 1 is 9. So that's our gradient is 9. We already have our point. Where did I get the x equals -2? Well, I got the -2 from the point here. That's our x coordinate. Popping into our equation of our line, y minus b equals m brackets x minus a. Y minus minus plus 5 equals 9 brackets x minus minus plus 2. Multiply out the bracket, y add 5 equals 9x add 18. Take the 5 over, y equals 9x plus 13. Or one of the other equations of a line. Looking at another example, this time we've only been given the x coordinate. So we need to find the gradient of the point. So I'll do the point first. So the point is the y equals equation. So y equals 1 over root x. So 1 over root 4, which is 2. So 1 over a half. So our point is 4 a half. Our differential equation, we need to put this into differentiable form. So y equals x to the negative a half. So dy by dx is negative a half x to the -3 over 2, which is 1 over 2 square root x cubed. At x equals 4, m, our gradient, which remember is our differential function, is -1 over 2 square root of 4 cubed. Square root of 4 is 2, 2 cubed is 8, times 2 is 16, so it's -1 over 16. So we then plug our point and our gradient into our equation of our line. So y minus a half equals -16x minus 4. Times 2 by 16 to clear the fraction. So 16y minus, well, half of 16 is 8, equals -1 brackets x minus 4. So -16y, 16y minus 8 equals -x plus 4. So take the x over, bring the 8 back, we get x plus 16y equals 12. Last example, this time we've been told the gradient, so we have to find our point, ask for the point of contact. What it might do is might go on and say find the equation of the tangent, in which case we need the point of contact to be able to sub it into our equation of our line. So dy by dx equation, here's our point, here's our equation, y equals x squared minus 3x plus 1. So dy by dx equals 2x minus 3, and that equals 7. So add 3, so 2x is 10, so x is 5. So we know what x is, so we can sub x into our y equals equation. So y equals 5 squared minus 3 times 5 plus 1. So 25 minus 15 add 1 is 11. So our point of contact is 5, 11.